Good morning, and welcome to the boardroom of the National Transportation Safety Board. I'm Vice Chairman Bella Dinzar, and it's my privilege to chair this meeting of the NTSB. Joining me today are Member Robert Sumwalt and Member Earl Weiner. Consistent with his ethics obligation, Chairman Christopher Hart has recused himself from the investigation that we're discussing today. Today, we meet in open session, as required by the Government in the Sunshine Act, to consider a fatal runway overrun during a rejected takeoff at Lawrence G. Hanscom Field in Bedford, Massachusetts on May 31st, 2014. The accident involved a Gulfstream G4. The privately owned and operated business jet rolled beyond the paved overrun area and subsequently crashed into a ravine where a post-impact fire ensued. Tragically, the two pilots, the flight attendant, and all four passengers on board died. On behalf of my fellow board members and the entire NTSB staff, I'd like to extend our sincerest condolences to the families and friends of those who lost their lives in this accident. We know that nothing can replace your loved ones, and we hope that the information that we discuss today will answer some of your questions. Please understand that in fully and frankly examining what went wrong, it's our purpose to identify ways to prevent similar accidents in the future and to minimize the harm from the accidents that do occur. In a moment, staff will present the facts and analysis of the accident. Much of this investigation centered on a mechanism called a gust lock. As the name implies, the gust lock prevents wind gusts from moving the airplane's flight control surfaces and damaging them when an aircraft is parked. When the gust lock is disengaged, pilots can move the flight control surfaces, such as the elevators, ailerons, and rudder, to control an airplane's movement. But as this flight crew prepared for takeoff, the gust lock remained engaged. Simply put, an airplane cannot take off safely with the gust lock engaged. As our investigators examined the data about this accident flight, they found that the flight crew routinely neglected performing complete flight control checks. These checks would have identified that the gust lock was still engaged before taxiing the aircraft for takeoff. Each of the two pilots involved in this accident had thousands of hours of flying time. Their training and medical certificates were current. They had flown together for years as pilots on the accident airplane. Complying with checklists, standard operating procedures, and company policies, referred to as procedural compliance, is critical to safe aviation. This is not the first accident in which our investigators have found procedural noncompliance. In fact, strengthening procedural compliance is presently on our most wanted list of transportation safety improvements. This investigation raises important questions about how this flight crew developed a long-term pattern of procedural noncompliance. What quality assurances could have identified these lapses? And more importantly, is this procedural noncompliance a prevalent practice in the business aviation community? Mechanical protections in the design of the gust lock should prevent pilots from attempting to take off with the gust lock engaged. This raised additional questions about whether those protections were implemented in the Gulfstream G4, whether the FAA sufficiently reviewed the Gulfstream G4 design, and also whether a different review method could have uncovered a deficiency in the design of the gust lock mechanism. Finally, our investigation looked at the emergency response of the Airport Rescue and Firefighting, or ARF, in this accident, in order to provide lessons learned for ARF operations both at Hanscom and other airports in the future. Now, Managing Director Tom Zoller will introduce the staff. Mr. Zoller.
Good morning, Madam Vice Chairman, Member Sumwalt, Member Weiner. Before I introduce the staff, I'd like to remind those in the audience, if they've not already done so, to please silence or turn off all their cell phones or other electronic devices. In the event of an emergency, there are 3 exits from the boardroom, 2 on either side of the dais and 1 in the rear where we all entered. And in the event of a cardiac emergency, there is an AED located on the far wall in the lobby of the boardroom. This morning, the staff members of the board seated next to me, on my right and working my way down, is John DeLisi, the Director of the Office of Aviation Safety. Next is Luke Sciatta, who is the investigator in charge of this accident. Next to Mr. Sciatta is Mr. Adam Hurry of Airworthiness, Dr. Bill Bramble, Human Performance, and Pete Wentz, Survival Factors. Behind Mr. Wentz is Jeff Marcus from the Office of Safety Recommendations. To his left, Tim Sorensen, Operations. Mike Hoff, System Safety. Next to Mr. Hoff is Jim Ritter, the Acting Director of the Office of Research and Engineering. David Toshin, the General Counsel. And Sharon Bryson, the Director of the Office of Communications. Behind Ms. Bryson sits Charles Cates, who is working the visuals and the timer. Then Chris Babcock, Flight Data Recorder. Joe Greger, Cockpit Voice Recorder. Next to Mr. Greger is Adrian Lamb, Materials Analysis. And John O'Callahan from Airplane Performance. And pinch hitting for Georgia Strushaker is Karen Stein, the report writing. And I think Mr. Sciatta has the opening presentation.
Good morning, Vice Chairman Dinzar, Member Sumwalt, and Member Weiner. On May 31st, 2014, about 2140 local time, a Gulfstream Aerospace Corporation G4, owned by SK Travel LLC and operated by Arizon Ventures LLC as a Part 91 corporate flight, crashed after it overran the end of runway 11 during a rejected takeoff at Lawrence G. Hanscom Field in Bedford, Massachusetts. The 2 pilots, a flight attendant, and 4 passengers were fatally injured. Night visual meteorological conditions prevailed at the time of the accident. The airplane arrived at Bedford about 15:45. After landing, the flight crew engaged the Gust lock system, which locks the airplane's primary flight control surfaces to protect them from wind gusts while parked. The passengers left the airport while the flight crew remained with the airplane. The passengers returned about 6 hours later for a return flight to Atlantic City, New Jersey. The flight crew did not disengage the airplane's Gust lock prior to engine start. The Gust lock system includes a mechanical interlock that was intended to restrict the movement of the throttle levers when the Gust lock was engaged to prevent an unsafe takeoff. Staff's investigation found that the throttle lever movement allowed by the interlock on the accident airplane was 3 to 4 times the design intent. During the 11 minutes from the time that the passengers boarded the airplane to the time that the airplane reached the runway, the pilots made no mention of checklists or takeoff planning. The pilots also did not perform a flight control check before the takeoff attempt, which would have alerted them of the engaged Gust lock. Analysis of data from the airplane's quick access recorder revealed that the accident pilots neglected to perform a complete flight control check during about 98% of their previous 175 flights. An animation of the accident was created using information from the airplane's cockpit voice recorder and flight data recorder. The animation begins with the airplane, which is shown 3 times larger than the scale of the animation, taxiing onto the runway in preparation for takeoff. At this time, if you do not wish to view the animation, you may exit the boardroom, and those watching by webcast may wish to temporarily turn away from their display. Please play the animation. The animation does not depict the night lighting conditions that existed at the time of the accident. Certain system parameters or settings are shown, but these displays are not intended to mimic the actual displays in the cockpit. Selected comments from the CVR transcript attributed to the pilot in command, PIC, and second in command, SIC, appear as text at the time indicated in the transcript on the left side of the display area. Based on a review of previous takeoff attempts, the flight crew likely targeted an engine pressure ratio setting, or EPR, of 1.7, which is shown with a green horizontal bar. In addition, there are indications for activation of the auto throttle, flight power shutoff valve handle, or FPSOV, brakes, and thrust reversers. The animation is first shown at 1/3 speed and then plays again at actual speed. The animation begins as the airplane turns from the taxiway onto the runway. While taxiing onto the runway, the flight crew discussed the activation of the rudder limit light. These comments indicated that they had observed a blue rudder limit advisory message consistent with rudder movement with the gust lock still engaged. With the gust lock engaged, the throttle levers should have been restricted from providing an engine pressure ratio capable of enabling the airplane to reach takeoff speed. However, in this case, the gust lock system did not limit the motion of the throttle sufficiently to prevent an unsafe takeoff. The brakes were released and the throttles were advanced manually until they reached a restriction corresponding to an engine pressure ratio of about 1.4. This setting was substantially less than the normal target engine pressure ratio of 1.7 typically used by the pilots. The auto throttles were engaged and engine pressure ratios began to increase towards their maximum attained value of about 1.6 before reducing to about 1.5. As the engine pressure ratios reduced, the pilot in command commented couldn't get it manually any further, which suggests that he was aware of the restriction in the throttle lever movement. The second in command called out that the airplane had reached a speed of 80 knots. About 6 seconds later, the second in command indicated the airplane had reached takeoff decision speed, V1. The second in command then called rotate. 1 second later, the pilot in command said steer lock is on. The pilot in command repeated this statement 6 times during the next 12.7 seconds. About 7 seconds after the rotate call, one of the pilots activated the flight power shutoff valve, which removed the hydraulic pressure from the primary flight controls and ground spoilers, likely in an attempt to release the gust lock. About 11 seconds after the rotate call, brake pressure started to rise. This occurred at a ground speed of about 162 knots and with about 1,400 feet of runway remaining. 4 seconds later, the throttle levers were pulled back and the pilot in command said, "I can't stop it." The airplane exited the runway onto the paved overrun and the thrust reversers were deployed. The airplane exited the paved overrun onto the grass, traveling about 105 knots. The sound of an impact was recorded about 1 second later at a ground speed of about 97 knots, followed by the end of recorded data. The animation is shown again at actual speed with abbreviated comments. As the airplane taxied onto the runway, the flight crew discussed the blue rudder limit advisory message consistent with the gust lock still engaged. After the brakes were released, the throttles were advanced manually until they reached a restriction which corresponded to an engine pressure ratio of about 1.4. The auto throttles were engaged. The second in command called out that the airplane had reached a speed of 80 knots. The second in command stated the airplane had reached takeoff decision speed, V1. One of the pilots activated the flight power shutoff valve, likely in an attempt to release the gust lock. Brake pressure started to rise. The thrust reversers were deployed. The airplane collided with runway lighting and a localizer antenna and passed through the airport's perimeter fence before coming to rest in a ravine formed by the Shawsheen River. The main wreckage came to rest about 850 feet past the end of the paved runway overrun and was destroyed by a post-crash fire. The arrow on this slide shows the point on the runway during the takeoff attempt where an overrun beyond the paved surface was inevitable. Performance calculations indicated that if the rejected takeoff procedures outlined in the airplane flight manual had been applied up to about 11 seconds after the first lock is on comment, the airplane could have stopped on the paved surface. The impact forces in the accident were survivable, but the cabin and cockpit environment quickly deteriorated due to the post-crash fire, which erupted immediately and prevented the occupants from escaping. Staff identified the following safety issues during this investigation: the need to redesign and retrofit the Gust lock system on all existing G4 airplanes so that the pilot receives an unmistakable warning that the lock is engaged at the start of takeoff, the lack of guidance regarding the use of engineering drawing review as a means for showing compliance with certification requirements, the importance of using the challenge verification response format for checklist execution, the need to analyze data to define the scope of procedural noncompliance in business aviation, and the replacement of non-frangible fittings with frangible fittings for any objects along the extended runway centerline up to the perimeter fence. Staff has proposed safety recommendations in these areas. In addition, staff has proposed a safety alert to advise pilots that the use of checklists can prevent procedural omissions. During this investigation, NTSB staff were assisted by party representatives from the Federal Aviation Administration, Gulfstream Aerospace Corporation, Massachusetts Port Authority, Honeywell International, and Rockwell Collins. An accredited representative from the UK Air Accident Investigation Branch and a technical advisor from Rolls-Royce UK also participated in the investigation. I would also like to acknowledge the NTSB staff who participated in the investigation. This concludes my presentation. Mr. Hooray will now discuss airworthiness and certification issues.
Good morning. I will discuss some of the airworthiness issues related to the G4 Gust lock system and certification. The G4 airplane incorporates a gust lock system to lock the ailerons, elevators, and rudder to protect them against wind gust loads when the airplane is not hydraulically powered. The system is controlled by operating a red handle located on the control pedestal assembly in the cockpit. In these photos, the handle is shown in the up position, engaging the gust lock. When the gust lock handle is in the up position, mechanical hooks lock each primary flight control surface. The gust lock hook mechanism for the ailerons is located under the fuselage floor, and the mechanisms for the rudder and elevators are located in the tail compartment. When the gust lock system is engaged, the ailerons and rudder are locked in the neutral position, and the elevators are locked in the full down position. The FAA certification requirement for gust lock systems requires that, if the gust lock is engaged, it must either automatically disengage when the flight controls are operated or limit the operation of the airplane so that a pilot would receive unmistakable warning at the start of takeoff. Regarding this regulation, the FAA stated to the NTSB that it considered an unmistakable warning to be a warning that physically limits the operation of the airplane to prevent an unsafe takeoff. Gulfstream's method of compliance with the gust lock regulation was to limit throttle advancement to a throttle lever angle, or TLA, of 6 degrees, which would prevent the airplane from achieving takeoff speeds. To limit the advancement of the throttle levers, Gulfstream incorporated a gust lock throttle lever interlock mechanism into the pedestal assembly. This mechanism allows full throttle lever travel when the gust lock handle is in the down position, and was intended to limit throttle lever travel to 6 degrees when the gust lock handle is in the up position. Post-accident testing on the accident airplane found that when the gust lock handle was in the up position, a TLA of 22 degrees could be achieved before the interlock mechanism prevented further throttle advancement. A TLA of 22 degrees can allow the airplane to reach takeoff speeds. A post-accident analysis found that the interlock design could allow for TLA values as high as 23 degrees when worst-case tolerances were considered. In addition, a post-accident inspection of 9 in-service G4 airplanes found that each of the inspected airplanes could achieve TLA values 3 to 4 times the design intent when the gust lock handle was in the up position. Therefore, staff believes that the gust lock system, when engaged, does not meet the design intent of limiting throttle lever advancement to 6 degrees or the certification requirement intent to limit the operation of the airplane to provide an unmistakable warning. In response to the accident investigation, Gulfstream released 2 separate maintenance and operations letters to remind G4 operators of the importance of performing flight control checks before flight. Specifically, the letters reminded operators to check flight controls for freedom of movement before taxi and takeoff, and that throttle lever movement is not an absolute indicator of the gust lock status. Gulfstream also began work on a modification to the G4 interlock to ensure the gust lock system would meet the intended certification requirements. Once Gulfstream completes the modification, the FAA will be responsible for mandating the modification. Staff has proposed a recommendation in this area. Gulfstream's compliance with the gust lock certification requirement was demonstrated by a review of engineering drawings only. Gulfstream did not perform and was not required by the FAA to perform any engineering certification test or analysis. Staff believes that had verification testing or analysis been required, it would have identified that the system did not meet the certification requirements. Although drawing reviews alone may be acceptable for some systems to show compliance, there is no guidance available from the FAA to identify when the use of drawing reviews can appropriately be used. Staff has proposed a recommendation in this area. This concludes my presentation. Dr. Bramble will now discuss flight crew use of checklists and procedural noncompliance.
Good morning. The flight crew involved in this accident was properly certificated and fit for duty. The pilots were also highly experienced. The pilot in command had more than 11,000 flight hours and more than 1,600 hours in the G4. The second in command had more than 18,000 flight hours with more than 3,000 hours in the G4. The 2 pilots had been flying together at SK Travel for about 12 years, 7 of which they spent flying the accident airplane. Despite their experience, the pilots made 2 key errors. They neglected to release and stow the gust lock, and they neglected to perform a flight control check. The flight crew's neglecting to release the gust lock was an unintentional error of omission. This is a common form of error, and similar errors involving the omission of normal procedural steps have played a role in about 20% of flight crew-involved major accidents. Checklists are an important defense against such errors. Cockpit voice recordings indicated that the flight crew did not call for any checklists or verbalize any checklist items during the attempted takeoff. A pilot who had previously flown with the PIC said this was typical for him because he had memorized the G4 checklist. However, executing checklists silently and from memory removes many benefits and increases susceptibility to error. The standardized use of checklists is a foundation for effective crew resource management. It assists flight crews with recall of steps for configuring the airplane, specifies a logical sequence and distribution of workload, enhances cross-checking, and supports shared awareness of the airplane's configuration. For optimum benefit, key checklist items should be called out using a challenge verification response method. This method involves having the pilot monitoring read an item aloud, having the flight crew verify that the required action was performed, and having the pilot flying provide a standard verbal response. SK Travel required its pilots to complete all appropriate checklists. However, company policy did not specify a preferred method of checklist completion. An independent safety audit of SK Travel verified that the company had appropriate checklists and that the checklists were used during pilot proficiency checks. However, the audit did not examine whether company policy specified a preferred method of checklist completion. Staff has proposed a recommendation in this area. Although the after starting engines checklist included an item that involved moving the elevators, ailerons, and rudder stop to stop to confirm that they moved freely and correctly, the pilots did not perform a flight control check at any time before the attempted takeoff, and they did not complete a flight control check before 98% of their previous 175 takeoffs. This indicated a consistent pattern of procedural noncompliance. Procedural noncompliance can increase the likelihood of subsequent errors. There are many possible reasons for procedural noncompliance. Explanations have included personality, workload, and goal conflicts. However, the consistency of this flight crew's noncompliance suggests the development of shared attitudes regarding the necessity of performing the flight control check. When flight crews perform routine checks over a long period of time without discovering any problems, they may begin to regard such checks as less important, and actual operating practices can diverge from published procedures, a phenomenon known as procedural drift. Small operators with more consistent crew pairings and less oversight may be at increased risk of procedural drift due to increased opportunities for the operating practices of a single crew to drift in parallel and not be detected. The extent of noncompliance with required flight control checks in corporate aviation is currently unknown. If the rate of noncompliance with such checks is high, the industry may need to make efforts to boost compliance or reconsider assumptions about the protection such procedures currently provide, particularly among small operators. Analysis of corporate flight operations data could help scope the problem and guide industry safety initiatives. Staff has proposed a recommendation in this area. This concludes my presentation. Mr. Wentz will now address survival factors.
Good morning. I will be discussing the survival factors related to this accident, including occupant survivability, the emergency response, and frangibility of support structures located on airport property. According to one of the air traffic controllers, the post-crash fire erupted almost instantaneously, with the airplane coming to stop in a ravine. It is likely that the fire was near the wing root area of the fuselage, rendering the airplane's overwing emergency exit windows unusable and blocking access to the aft baggage compartment door. Therefore, the only viable exit was likely the main entry door on the forward left side of the fuselage. Although post-accident examination of the main entry door's locking mechanism found the door to operate normally, the occupants did not open it prior to being overcome by fire and smoke inside the airplane. Hanscom Field was owned and operated by the Massachusetts Port Authority, or Massport. The airport was a joint-use civil and military airport, and at the time of the accident, the Hanscom Air Force Base Fire Department performed firefighting services under a contract between Massport and the Department of Defense, or DoD. The investigation identified several issues with the emergency response, and although staff believes these issues did not affect occupant survivability, we do believe they represented lessons learned from Massport, the FAA, and the DoD. For example, after arrival on scene, our vehicles conducted continuous firefighting activities for about 25 minutes until each vehicle's water supply was exhausted. However, there was then a 14-minute period when no water was applied to the fire because a resupply hose had not been dropped at a fire hydrant en route to the accident site when the vehicles drove past it. A short time later, a firefighting vehicle attempted to reach the nose of the airplane by using an airport perimeter gate that did not provide access to the opposite side of the ravine. Another perimeter gate did provide access. However, the location of this gate was not shown on the grid map in the airport's emergency plan or in the ARF vehicles. Massport has already addressed some of these issues and plans to establish and operate a new ARF facility at Hanscom Field in November of 2015. Finally, I'd like to discuss frangible fittings, which are breakaway mechanisms for structures on airport property. After leaving the paved runway overrun, the airplane struck the approach lighting system, a localizer antenna, and the airport perimeter fence, which were outside of the runway safety area, or RSA. These structures were not mounted on frangible fittings, nor were they required to be, because the FAA mandates that only structures inside the RSA have frangible fittings. The structures damaged in the accident were outside the RSA, and they likely substantially damaged the airplane during the overrun. The photograph on the left shows a localizer support with frangible fittings that are used to anchor it to the concrete base. The photograph on the right shows a frangible fitting. Note the two machine grooves in the connector that are designed to break should the structure sustain a significant impact. After the accident, frangible fittings were used when replacing the damaged structures, and even though they were outside of the RSA, the FAA states this was done in order to enhance safety. Staff recognizes that the FAA already encourages the incorporation of frangible fittings in areas adjacent to RSAs. However, staff is concerned that the FAA currently has no method for identifying non-frangible structures outside of the RSA or for prioritizing their replacement whenever feasible. Staff has proposed a recommendation in this area. Thank you. This concludes staff's presentations.
Thank you, Mr. Wentz, and thank you to all of the staff for your very thorough and excellent presentations. Now we'll begin the question and answer session, and we will begin with Member Sumwalt.
Thank you, Vice Chairman Denzar. Well, this morning we are talking about very pointed things. We're talking about things that people didn't do, but they should have done. And I know that's very painful to hear, but it does not take away from the good people that these people were. But in order for us to do our job at the NTSB, we need to call it the way that we see it. We need to take a very hard look at these errors so that we can learn from them, so that we can keep them from happening again. And that's exactly why we are here. Let me ask a question about the validity of the quick access recorders, and this might be for Mr. Shiata or for Mr. Hure. You mentioned that of the 175 prior flights, there was no indication of a complete flight control check. Is there any question about the data that we received from that QAR?
The QAR took its data directly from the flight data recorder. The flight data recorder recorded 25 hours of data, and there was approximately 303 hours of data recorded on the quick access recorder, which was directly taken from the FDR, so we believe the data is valid.
Thank you very much. The way I look at our aviation system, it's built on a series of layers of defense. And in this particular case, when we're trying to prevent a takeoff with the Gust lock on, there are several layers of defense. One would be the checklist. And the Gust lock was the fourth item on the starting engine's checklist. But it was only the second item that the crew actually had to do. The other item was, the other two items were just verify something. So one thing was they had to press a button to pull up a screen on their ICAS screen, and the other action would be to release the Gust lock. So this was the fourth item on the checklist. Another layer of defense would be a flight control check. Again, this was an item on checklist, and it was also a procedure that would be accomplished during the takeoff roll between 60 and 80 knots to make sure that the elevator, that the yoke did come back to its neutral position. Another layer of defense would be that there's supposed to be a mechanical stop to prevent the throttles from being advanced to take off thrust if the Gust lock is on. But clearly we had holes of defense, holes in each of these layers of defense. So let's talk about the flight control check. Well, let's talk about the checklist first. How many checklists did the cockpit voice recorder indicate that this crew omitted on this particular attempted flight?
There was no verbalization of any checklists, and there were 5 checklists.
5 checklists that should have been done, and no evidence that they were verbalized.
That is correct.
Now, the flight control checks, we mentioned that for over 98% of the past 175 flights, they did not do a full flight control check. Now, Dr. Bramble, we don't need to pull it up, but on slide 29, I think you said they did not do a flight control check. I think that really is they did not do a complete flight control check on 173 out of 175 flights. Am I correct?
Yes.
So what do you mean by a full flight control check? And what percentage of the flights did they do any attempt at a flight control check? Or it doesn't have to be a percentage, it can be a number.
Well, a full flight control check would be moving each of the controls, major flight controls, through its complete range of motion to ensure that it's free and correct. They only did that, as you said, 2 times out of the 175, which makes up 2% of the 175. They did a partial flight control check, which means moving one or more controls through at least some portion of that range in 10% of their takeoffs.
Okay, thanks. So no attempt for a flight control check for 90% of the flights. Did I say that correctly?
Correct.
No flight control check for 90% of the flights. I think so. You know, this is not just something that's generic to the Gulfstream G4. Before every takeoff for whatever airplane you're flying, a flight control check should be done. This is not just unique to this airplane. I flew for 32 years. And not that I'm the greatest pilot in the world. I made plenty of mistakes. But I do know that a flight control check should be done before every takeoff. So I'm out of time. Thank you.
Thank you, Member Sumwalt. Member Weiner?
Thank you, Vice Chairman. As Member Sumwalt's already pointed out, there are multiple layers of defense, both in the operation and in the design of the airplane. Excuse me, in the operation of the airplane, there were a couple of checklists that would have caught the airplane not being in a takeoff configuration. I'd like to spend some time talking about the layer of protection related to the airplane. The airplane was designed so that it could not, at least the intent was that the airplane could not be taken off with the flight control gust lock on engaged. And that was supposed to be done by the throttle limited to 6 degrees of motion. What is the history of this throttle quadrant or this gust lock system? When was it first designed, and when was it first certificated?
The throttle system and gust lock system was originally certified on the G2 or Gulfstream G2 aircraft in 1967. The gust lock system on the G2 and G3 are identical systems. G4 is different.
And what's different about the G4 from the Gulfstream 2 and 3?
The gust lock lever has a longer range of travel. I believe went from 60 degrees of travel up to 87 degrees.
Do we have any history of this aircraft or the initial certification on the Gulfstream 2 conforming to 6 degree of motion limitation?
I don't believe so.
Do we know what the limitation was on the Gulfstream 3 implementation?
The testing showed that when gust lock was in its up engaged position on the G3, the throttles would be limited to 14 degrees and did not meet the 6 degree requirement.
And the throttles in this case were limited only at 23, 24 degrees, is that correct?
Correct.
And this was a certified installation. What does that mean? What are the requirements that it has to comply with?
For the gust lock requirement, FAR 25679, it was, aircraft was supposed to provide an unmistakable warning to the flight crew at the start of takeoff. Gulfstream's design was intended to limit the throttle movement to 6 degrees in order to meet that requirement.
So had it been limited to 6 degrees, well, it wasn't limited, it was in this installation allowed takeoff speed to be attained, but had it been limited to 6 degrees, what kind of aircraft movement would have been possible with a 6-degree limitation? Would it get out of the chocks? Would it taxi? Would it, how fast would it go?
We did ask Gulfstream that question, and they replied that for the G4, a 6-degree throttle lever movement will not allow you to reach takeoff speeds. That was the response. I don't know exactly how fast you can get. There's a number of variables you would have to know in order to get that calculation, but you cannot reach takeoff speeds.
Mm-hmm. Was it known that you could disengage the gust lock system after the engines had been started, contrary to the checklist?
We had statements from other pilots that said that procedure was known in the G4 community. That procedure is not approved by the manufacturer, and it's not in the manuals anywhere.
But it was kind of common knowledge, you say, in the pilot community. To what point in the takeoff process could the gust lock be disengaged?
Well, it's our understanding that the gust lock should be released before hydraulic pressure, before the engines are started, before hydraulic pressure is put on the airplane. After that, loading on the gust lock hooks can prevent that in some instances.
Even with the flight power shutoff valve activated?
That's correct. And
Okay.
if I may, can I just add one additional point regarding the differences between the G2, G3, and G4? A significant difference is the different thrust ratings in the engines between the G2, G3, and G4, where a given throttle lever movement on the G4 will result in a lot more engine power than you would have on a G2 or G3.
Thank you.
Thank you, Member Weiner. To follow up on Member Weiner's questions about the flight power shutoff valve, how do we know when the flight power shutoff valve was pulled? Was it recorded on the FDR?
The flight power shutoff valve position is not recorded on the FDR. However, you can tell by the effects of losing hydraulics to certain systems whether or not the flight power shutoff valve was pulled. In this case, we see that spoilers float, we see ailerons float, and we also see that the yaw damper disengages, and all those happen at the exact same time, which is a good indication of flight power shutoff valve being activated.
Thank you, Mr. Hooray. And is there anything that we have in the data that we recovered that would indicate whether the crew ever used the flight power shutoff valve before this occasion?
We're not able to determine if it had been used on any prior flights.
Okay, thanks, Mr. Sciatta. So, going back to the gust lock, how can we know that the gust lock handle was in the up position at the start of takeoff? Could you explain how we know that? Because I just want to make sure that that the handle couldn't have been released, but because of some system failure, it didn't engage the hooks, for example.
Well, we know we have a restriction that occurs early on, and it restricts throttle lever movement to about 17.5 degrees PLA. That position is directly related to the gust lock handle position. not so much the hooks in the back, but actually where the handle position is. So because we know we hit a restriction there, that 17.5 degrees is consistent with a gust lock handle being in an up and locked position.
Thank you. So did we do some testing to show that the gust lock was in the full on position rather than in the intermediate? And after it came to rest, I understand that the gust lock was actually in the off position. So could you tell us how it unlocked during this period?
Sure. Well, we did do lots of testing following the accident to try to determine a range depending on the position of the gust lock handle. We looked at 4 aircraft and we were able to develop a range of PLAs and TLAs, and we were able to use that data to look at what's on our FDR and try to correlate. Do you mind asking the second part of your question?
Sure, sorry. I did a 2-part there. So the second part is when the aircraft came to rest, the gust lock was in the off position. And how do we know that that it became unlocked? Do we have a scenario for that?
The gust lock, the lock pin in the gust lock handle was found broken. The gust lock lock pin is responsible for maintaining the gust lock handle in the up and locked position. So with a broken pin, you don't necessarily have your restraining force to keep the gust lock handle up anymore, and any forces can pull the handle down.
Thank you. So could you describe, not necessarily you, Mr. Hooray, but maybe Mr. Sciatta, any remedial measures that Gulfstream has taken to prevent future accidents in the G4s that are in operation now?
Well, Gulfstream, as Mr. Hooray mentioned in his presentation, Gulfstream did issue the 2 maintenance operator alert letters in order to provide information to its operators, and also they're redesigning the gust lock mechanism to actually meet the design intent and provide a restriction so that the airplane is not able to reach takeoff speeds.
Thank you. I think I'm out of time, so we'll start our second round of question and answers. Member Sumwalt.
Thank you, Vice Chairman. Mr. Hooray, to add to the answer that the Vice Chairman asked about what indications do we have that the gust lock was in fact engaged, would the rudder limiter enunciation be yet another indication of that? And if so, discuss that.
Yes, the rudder limiter, the rudder limiter will limit the pressure within the actuator to protect structural overload on the tail. And typically, you would get to that position by hitting a stop. You put a command into the rudder pedals, and as the actuator pushes, it would come up against the stop, and it will build pressure until the rudder limiter cuts off. So we know from looking at FDR data that the rudders don't move more than about a degree and a half left to right. There's no other stop available to cause the rudder limit light to trigger other than gust lock.
Thank you. And yet another indication, too, that we know the gust lock was engaged was that we look at the flight control positions, and we know that the elevator, for example, was at 13 degrees trailing edge down, which would be consistent with the gust lock being applied. Is that correct?
That is correct.
So we had numerous indications that the gust lock was, in fact, on when this airplane taxied out and when the takeoff roll was initiated. Thank you. So while I've got you on the hook, you talked about this pin. So the pin was broken. What would that indicate? Would that indicate force on the gust lock handle?
Well, the pin will counter the loads that could come from either manual pushing on the gust lock handle. You could have manual advancement of the throttle levers acting against the interlock, or you could also have auto throttle acting against the interlock. Any of those will apply forces that are countered by that pin.
Thank you. Mr. Sorensen, I want to ask you this. You are the operations group chairman for this investigation. Could the crew have completed their training at Flight Safety International, which they had completed in September, could they have done that if they did not follow checklist or if they did not complete flight control checks?
No, all of those, both the complying with the checklist and the flight control check, was part of the standard training that they received.
You could not pass a check ride if you didn't do checklist or if you didn't do the required checklist.
That is correct.
So really, that sort of shows that the crew knew what they were supposed to do. They knew what was required of them, but yet, for whatever reason, they elected not to do it. Not just on this flight, but on 90% of their previous flights, or 98% of their previous flights, that they did any flight control check. So it appears that this, from my perspective, is just plain and simple a case of pilots intentionally disregarding procedures. Now, Dr. Bramble, you mentioned on slide 24, you said this was probably an unintentional error of omission, but that's not to be confused from an intentional noncompliance. Am I correct there?
Correct. Two different types of errors, yeah.
So you also mentioned procedural drift. I've used the term normalization of deviance. I just mentioned the term intentional noncompliance. What do these terms really mean? How does somebody get there, and how do you avoid getting there?
Well, what they mean is that over time, crews can, their actual operational practices can diverge from written guidance. This is this procedural drift phenomenon that I mentioned. And in small groups, especially consistently paired groups, new norms can develop where these different practices become accepted as the way that things are done. Airlines combat this type of drift aggressively by re-emphasizing standard operating procedures and monitoring flight crew performance on the line through flight data monitoring programs. And they also have large workforces with interchangeable pilots who have to function in a standardized way to be able to work together effectively.
So we've got proposed recommendations that come out to the business aviation community to better monitor these flights, not necessarily to spy on particular flight crews, but to do a flight data monitoring program to see what the trends are within the business aviation community. Is that correct?
Yes.
Thank you.
Thank you, Member Sumwalt. Member Weiner?
I'd like to go back to the certification process for a few moments here. This airplane was certified to the Federal Air Regulations, the FAR's Part 25, so it's a transport category airplane. And typically, the means of showing compliance with the requirements are a demonstration, either flight test, ground test, analysis, or showing that it's similar to previous designs that have been certified before. How was this aisle stand in the G4 certified?
According to a Gulfstream compliance checklist, the compliance for the Gust lock requirement was done by a drawing review, or a review of engineering drawings.
And what does that entail?
Basically, design review or drawing review is a review of an item such as a document or a drawing to determine that the data shown on the drawing does comply with the regulations.
But there's no test involved. Had this been tested or subject to a ground test or a flight test, well, ground test in this case, what would it have shown?
Had this, the Gust lock system been tested with the Gust lock handle in the up position, test could have shown that the movement of the throttles would have exceeded the 6-degree requirement.
And the changes that Gulfstream has made subsequent to the accident have changed the throttle lever angle restrictions to 6 degrees, is that correct?
They will change the restriction to meet the design intent of 6 degrees, and beyond that, it'll actually will call for a yearly continuous airworthiness check of the movement to verify that it's still within that limit.
Is there any information about, in the training realm, in the simulator training that the pilots go through periodically, of the Gust lock? Was that included in the training?
Yes, a description of the Gust lock was included in the airplane operating manual, and it was also included in the training documentation that we reviewed.
And was that exercised in the simulator?
Yes, removing and engaging and disengaging the Gust lock would normally be part of the procedures done in the simulator during training.
Of the checklist?
That's correct.
Yeah, thank you. Yield the rest of my time.
Thank you, Member Weiner. So it's a testament to the thoroughness of your investigation that sometimes we uncover things that, sadly, although they don't affect survivability in this case, they may help affect survivability in the future. So my next questions are related to that, to the emergency response that occurred. Could you tell us some of the key lessons that came out of this, although it, as indicated from your presentation, didn't affect the survivability of this accident? What are some of the key safety lessons? And also, could you tell us any of the remedial measures that Massport has taken with respect to emergency response as a result of this accident?
Sure. So this airport was a little bit different than a normal airport like Chicago, O'Hare, Boston, Logan, where it had a DOD ARF facility on the field that was responsible for the ARF services. And so I guess what I'm trying to say is that they were there for the initial response and came out to the crash site. We noted in my presentation that they didn't drop the hose for resupply. We had some gate location errors where they didn't use the proper gate to get to the other side of the ravine. So Massport has now hired a deputy chief that will now oversee the airport. Massport has put their own facility on the field itself. They have trained firefighters and an ARF truck. And so now, because they have changed it over back to a city organization, the FAA will be responsible for then oversight of that. When I spoke earlier about the DoD contract, that was where the DoD and the FAA have come upon an agreement to, whenever there's a DoD provider on the field, they have Massport then do the oversight. The FAA then has to ask Massport for that paperwork and go through that. So by Massport, providing their own airport, they've kind of taken care of those issues. They've changed their grid map to show the gate locations, and now they have their own ARF services.
Thank you, Mr. Wentz. That's very helpful, and I'm glad to see that people are taking, or organizations are taking action in advance even of the results of this report. So I think we hope that'll help prevent some of the deaths and injuries in the future. I think this would be a question for Mr. Sciatta. In looking at other Gulfstream G4 investigations that we're conducting, I know that we're currently investigating a takeoff accident involving a G4 in Colorado in February. Has this investigation been able to determine any similarities between that one and this one, or are you at liberty to discuss that?
Well, Mr. Sorensen, the operations group chairman on this investigation, happens to be the investigator in charge of that incident, so I'll defer to Mr. Sorensen.
The Eagle incident is not similar to the Bedford accident. They both occurred during takeoff, but that's the extent of the similarities. The Eagle event, they stated they did complete a flight control check, and the flight controls were free to move at that time, so there were no issues.
Thank you, Mr. Sorensen. So I have a bit of time, and thank you to Member Weiner for yielding his time. I know you mentioned that we are issuing or planning to propose safety recommendations to the aviation business community. Could you tell us how effective that can be in reaching the members, for example, of the NBAA, and how can the industry get a gauge on whether this type of procedural noncompliance is common or whether it's unusual? And could you speak to the reporting and the self-reporting and how we can ensure that we get the information we need and that the potential safety recommendation is effective? Dr. Bramble, I think, right? Yeah.
Sure, yeah. Many business operators voluntarily participate in a corporate flight operations quality assurance program called CFOQA Centerline. And the National Business Aviation Association, NBAA, played a role in setting up that program with the Flight Safety Foundation. And NBAA also holds a position of safety leadership within this sector of the industry and promotes a data-driven safety agenda. We think NBAA and its many member organizations is uniquely well-positioned to lead a project taking a look at the rate of noncompliance involving required flight control checks, such as the check we've been discussing here today.
Thank you, Dr. Bramble. I think we have time for another round if you have more questions. Member Sumwalt?
Thank you. You know, there's so many elements about this accident that really bother me, and certainly the tragic loss of life is the thing that bothers us all. But as somebody who really has been in the aviation business for over 40 years, and somebody who ran a flight department, a corporate flight department, for a few years, somebody who's gone out and preached safety and how to run a flight department, there are just things here that just I cannot wrap my head around that are really bothering me. Like this operation, these guys were operating a top-of-the-line business jet. I think anybody would love to be operating the type of equipment they were operating. The company had employment stability. The chief pilot had been employed by this operation for over 27 years. The pilot in the left seat had been employed there for 12 years. The flight attendant had been employed for 16 years. You don't see that a lot in corporate aviation. You see a lot of people moving around, but the fact that they were there for that long must indicate that this was a pretty good operation, a pretty good place to work. They did their training at Flight Safety International. They could have gone out and done it. I've seen people that just try and get by and do it as cheaply as they can, but no, they went to flight safety, which is one of the gold standards. The chief pilot was described as being very meticulous about the airplane's maintenance. And they had received this ISBAO, International Standard for Business Aircraft Operations, standard, something that I strived for when I was running a little Fortune 500 flight department. And they had received stage 2 of that, and they were working on another audit. And that's a hard process to go through. The auditor's comments were very favorable. They said, for example, the auditor for their last audit said the best practices are consistently employed in all facets of the program. They said the flight operations manual is remarkably well written and comprehensive. The safety culture within the department is shared among all team members. And it said a solid safety program maturing nicely. And I'm reminded of a statement that I heard a friend of mine said, and that is, you can fool the auditors, but never fool yourself. And from the fact that this crew was not doing checklist routinely. We know that from a previous pilot who had flown with the left seat pilot. We know they weren't doing flight control checks, and I think if you're acting that way, you are just fooling yourself. And that's what's so tragic. They looked like they had a really good operation. But you don't have a good operation if you're not following those procedures. I want to go now and switch to one of those other layers of defense, and that would be the mechanical aspects, the things that my colleagues have been talking about, the certification issues. And one of them I see on the top of page 44. It says that we know that Gulfstream is putting in place a fix so that this Gulfstream, the G4 throttle, will be limited to 6 degrees or less with the gust lock is on. And it says that once the Gulfstream has come out with this fix, if you will, the FAA will likely mandate the fix, and it will likely take between 6 and 12 months to mandate it. Is that correct, Mr. Sciatta?
That is correct. The airworthiness directive would come from the transport airplane director, and it would take 6 to 12 months.
So I'm going to offer my opinion on that. Here we have a known accident. We have a known problem. And after the manufacturer has designed a fix, there is something badly broken at the FAA if it takes 6 to 12 months to come out with a required fix. There's something badly broken with that process. And you don't need to comment on that, because I already have. I want to highlight something that's been said, and that is, according to the draft report, if the flight crew had initiated a rejected takeoff in accordance with the G4 AFM, Airplane Flight Manual, at the time the pilot in command first said the lock is on, up until 11 seconds after that comment, the airplane could have been stopped on the paved surface. But instead, they relied on trying to troubleshoot the problem while the airplane was traveling, accelerating 3.5 knots per second. So by the time they noticed that the lock was on, the speed had gone from 129 knots to 150 knots when he pulled the flight power shutoff valve. Is that an approved procedure? That if you're going down the runway and the flight controls don't move, that you pull the PFSV?
The FPSOV is designed for a flight control malfunction.
So it's not at all designed for something like this if you're going down the runway at 130 knots to pull that handle?
Not to release the gust lock.
So we looked at 9 G4s that are in service, and none of them were restricted to 6 degrees. In fact, the restriction with the gust lock on with throttle lever angle was between 18 and 23 degrees on the 3 that we looked at. Is that right?
That's correct. And it was nine airplanes.
9, yes, thank you. The thing is, how would a pilot know that his airplane was not in compliance, his or her airplane was not in compliance? I look at the Gulfstream Airplane Operating Manual, and it says that the power levers should advance to a maximum of 6% above ground idle with the gust lock engaged. And I look at the flight safety training material, and it says the power levers cannot be advanced more than 6% above ground idle. That's not right at all. It's 6 degrees. So how would a pilot know that if he or she wanted to go out and say, I'm the type of guy that I'd go out and test it? Well, it's wrong in the books. So how's a pilot supposed to know that my airplane's not in compliance? You found 9 airplanes that weren't in compliance. Any comments on that?
Well, yeah, I agree that the documents say 6%, which appears to be a typo. However, that is a small amount of travel. And so, although the pilot maybe cannot directly measure that or determine that, that's more of a maintenance action. They still would be able to understand that there should be limited travel, and 23 degrees is or 23%. Obviously, is a lot more than 6.
Thanks. And to your point, even 6% is more restrictive than 6 degrees because the full throttle movement, I think, from stop to stop is about 59 degrees. So 6% of 59 would be about 3.5 degrees.
Yeah, that's it.
So, okay.
That's correct.
Well, I've rambled on, gone over my time, but I don't have any more questions.
Thank you, Member Sumwalt. So as you can see, we are looking at every aspect, and I appreciate the other members looking carefully at all the different aspects. Just one last question, just to completely clarify this for me. We talked about a broken lock pin in the Gust lock previously. Could you explain why we know that that was not causal in the accident?
Well, we believe that when the lock pin actually broke, it was when the auto throttle was engaged. At that point, they had already achieved a throttle lever angle that could allow them to reach takeoff speeds.
Thank you. More questions? Okay. I think that ends our question and answer period. We will take a 15-minute break, and based on the clock in the back of the room, so what would that be? 10:56, we will return to resume the rest of the board meeting. Thank you.
Sorry for the distraction.
I know, I was going to ask you.
Yeah, that really threw me, sir.
Yeah, I know, right in the middle of Member Weiner's, so.
screenshots of you.
If you take your seats, we'll be resuming shortly. This board meeting is back in session, and we will proceed to deliberations. Managing Director Zoller, please read the proposed findings.
As a result of this accident, staff proposes 16 findings. 1, the flight crew was qualified to operate the airplane, and the use of alcohol or drugs, fatigue, and medical conditions were not factors in the flight crew's performance. 2, the flight crew failed to disengage the Gust lock system as called for in the starting engines checklist, and failed to conduct a flight control check as called for in the after starting engines checklist, during which the crew members would have detected that the Gust lock system was engaged. 3, given that the flight crew neglected to perform complete flight control checks before 98% of the crew members' previous 175 takeoffs in the airplane, the flight crew's omission of a flight control check before the accident takeoff indicates intentional, habitual noncompliance with the standard operating procedures. 4, about the time that the airplane reached a speed of 150 knots, one of the pilots activated the flight power shutoff valve, likely in an attempt to unlock the flight controls, but this action was ineffective because high aerodynamic loads on the elevator were likely impeding Gust lock hook release. 5, the flight crew delayed initiating a rejected takeoff until the accident was unavoidable. This delay likely resulted from surprise, the unsuccessful attempt to resolve the problem through the use of the flight power shutoff valve, and ineffective communication. 6, the flight crew members' lack of adherence to industry best practices involving the execution of normal checklists eliminated the opportunity for them to recognize that the Gust lock handle was in the on position and delayed their detection of this error. 7, independent safety audits performed by an industry safety organization did not adequately encourage best practices for the execution of normal checklists. 8, an analysis of corporate flight operations quality assurance centerline data, specifically evaluating the rate of noncompliance with flight control checks before takeoff, could help define the scope of procedural noncompliance in business aviation and guide the development of strategies to address it. 9, the impact forces from the accident were survivable, but the cabin and cockpit environment quickly deteriorated due to the post-crash fire, which erupted immediately and spread rapidly and prevented the occupants from escaping. 10. Had a resupply hose been placed at the fire hydrant in the vicinity of the accident site before the aircraft rescue and firefighting vehicles exhausted their water supply, the 14-minute delay in resuming firefighting activities could have been avoided. 11. Had the Lawrence G. Hanscom Field Airport Emergency Plan included a gate map, or had the perimeter gates been depicted on the grid map, the aircraft rescue and firefighting personnel's confusion about how to reach the non-airport side of the ravine would likely have been reduced. 12. The replacement of non-frangible fittings with frangible fittings on structures located outside of but adjacent to a runway safety area, or RSA, such as the approach lights and localizer antenna struck by the accident airplane, would minimize the potential for damage to an airplane that is unable to stop within the RSA during a runway overrun. 13. Because the Gust lock system in Gulfstream Aerospace Corporation G4 airplanes does not limit the operation of the throttle levers with the Gust lock engaged to provide an unmistakable warning at the start of takeoff, as was originally intended when the airplane was certificated, the Gust lock system on the G4 does not comply with 14 Code of Federal Regulations 25.679. 14. Gulfstream Aerospace Corporation's use of a G4 drawing review alone to show compliance with 14 Code of Federal Regulations 25.679 led to a Gust lock throttle interlock system that did not comply with the regulation. 15. If the Gulfstream Aerospace Corporation G4's Gust lock system had been developed using Gulfstream's current design process, Gulfstream would likely have developed, validated, and verified a Gust lock system that would limit the throttle lever movement to 6 degrees. 16. Without clear guidance, drawing reviews alone as a method of compliance may not be sufficiently robust to verify that aircraft certification requirements have been met.
Thank you, Mr. Zoller. And we do have some proposed amendments, and we'll start with Member Sumwalt. Okay. We will go in numerical order as suggested by So I would like to propose an amendment to finding number 10. I think it's important that we are making recommendations to affect future survivability of such accidents. But I think it's also important to recognize that in this case, since this report is about this specific accident, that unfortunately it was not survivable and this didn't affect it. So my proposed rewording is to add a clause at the beginning of finding number 10, and I will read that. So finding number 10. Although it did not affect the survivability of this accident, had a resupply hose been placed at the fire hydrant in the vicinity of the accident site before the aircraft rescue and firefighting vehicles exhausted their water supply, the 14-minute delay in resuming firefighting activities could have been avoided. I would like to move that we amend the findings with this additional clause to finding number 10.
Second.
Member Sumwalt seconds. Is there any discussion? We'd like to, does the staff also have a position on this proposed amendment?
Staff concurs.
Thank you, Mr. DeLisi. So do you have any other issues related to this specific amendment? Okay, so we will first vote on this amendment and then we will talk about other amendments that may come forward. So the motion to amend finding number 10 has been moved by me and seconded by Member Sumwalt. And those in favor, please signal with your hand and say aye. Aye. So the vote is 3-0 in favor of adopting the amendment to finding number 10 as amended. And the amendment has been adopted. So we will continue with, we are going in order, I believe that would be Member Weiner.
Okay, I propose the amendment to finding number 16, essentially to, it's editorial, in part to make it clear that the FAA is responsible for the type certification requirements. So to reading the amendment as proposed, without clear guidance, the use of drawing reviews as the sole method of compliance determination may not be sufficiently robust to verify that FAA aircraft type certification requirements have been met. My proposal.
Okay, and I second that. You move that, Member Weiner?
Yeah, seconded.
And so Member Weiner moves it, and I second it. If there is any other discussion among the members? No? No? Could we have any response from the staff then?
Staff concurs.
Okay. So I guess now I'm sorry, I went a little bit out of order. Is there so the motion has been seconded. So those in favor, please signal with a raised hand and say aye to Member Weiner's proposed amendment to finding number 16.
Aye.
Aye. And so the motion to accept the amendment by Member Weiner has been approved. And the vote is 3-0 in favor of adopting the findings, the amendment. I'm not sure if we were supposed to adopt all of the findings together, but we'll do that again, just to be completely within Robert's Rules of Order. Apologies to our General Counsel for going a little bit out of order. So Member Sumwalt also has an amendment. I suppose we all have amendments on the.
Indeed. I'd like to propose a new finding to be inserted at the place that staff feels would be most appropriate. I met with staff yesterday, and they were trying to decide exactly where to put it, so I would propose we leave it to them. And I propose this, my motion is that we insert a new finding to state the Federal Aviation Administration missed opportunities to detect the inadequate design of the Gust lock system during the Gulfstream Aerospace Corporation G4's certification because the FAA relied solely on a review of engineering drawings to determine if the system met certification requirements. And that is my motion.
Second. And is there any discussion among the members, first of all? Does the staff have a position on the proposed amendment?
We concur.
Thank you, Mr. DeLisi. So we have a motion and a second, and so now we will move to vote. Those in favor of Member Sumwalt's new finding, and the staff, are you agreeable, Member Sumwalt and staff, that it will be placed as appropriate, as you discussed? Will be placed in the appropriate spot in the findings. So those in favor, please signal with a hand and say aye.
Aye.
Aye. So the vote is 3-0 in favor of adopting the new finding by Member Sumwalt, and the amendment has been adopted. So is there a motion to adopt the findings in full as amended?
Madam Chairman, may I ask a question?
Yes.
Thanks. I don't care how many times we've read these things. Every time we read something, we wonder, we find something else. Let me ask a question. On finding 8, we say an analysis of corporate flight operations quality assurance centerline data. And is that a specific product of a specific company? I think that the centerline, Fuqua centerline, is a product of Austin Digital. And I want to make sure that we're not promoting a particular product. We want to promote the concept, but not necessarily be endorsing a product. How does staff interpret that? Once we started going into adding capital FOQA and then adding centerline, I think it took it from a generic sense to a very specific product.
Well, we are talking about a particular repository of data. It used to be called the CFOQA pilot project, and it was recently, as of last 3 years, I think, branded as the CFOQA Centerline program. And it has a users group that has members on a steering committee that guides it, that provides, that sort of is the gatekeeper for the data. And so it is that specific group that we're targeting, and that was how they represented themselves to us.
Is that a commercial entity? Is that a money-making entity? I think it is. GE bought Austin Digital for a bunch of money a couple of years ago. I don't know. What would your feeling be, Mr. General Counsel, on this, if it's a specific company? Are we okay? I like the concept of it, believe me. I just want to make sure we're okay from a legal perspective.
We would have to look into that a bit further.
So procedurally, if we adopted it, subject to your further review of that, would that be okay procedurally? Or Mr. DeLisi, I think you were going to say something.
If I could just add, in a moment, the board will be discussing the recommendations, but certainly that finding leads support to recommendation number 5. The entity that we're looking for the NBAA to work with in executing the recommendation is the Corporate FOQA, Corporate Flight Operational Quality Assurance Centerline Steering Committee. That's the name of the committee. So we use that same terminology in the finding that supports that recommendation.
Is there another group that provides the same kind of service and has the same kind of data repository?
The two biggest commercial flight data monitoring programs that we were able to identify are the CFOQA Centerline program and Gulfstream's Forms program, which is provided to Gulfstream customers, a similar kind of service, but also hosted by Austin Digital. There are a few other bit player, smaller entities out there, but the vast majority of the flight data monitoring in the corporate world is either CFOQA Centerline or Forms, and both are hosted by Austin Digital.
So this is really the only program that's open to all aspects of the corporate community. Is that correct?
I think that's correct. I'm not positive whether Gulfstream would provide the service to non-Gulfstream operators. We'd have to find out.
But these are the data that are provided, that are used by the NBAA. Is that correct?
Correct. NBAA has used data from the CFOQA repository to help determine and drive its safety agenda.
And they are the leading business aviation association in this country. Is that correct?
Yes.
Does that help answer your questions, Member Sumwalt?
Well, to be very clear, I certainly support the intent of the recommendation and the finding. I just want to make sure that we're not overreaching by, and I apologize for just bringing this up now, just in reading, as Mr. Zoller was reading the recommendations or the findings, that's when that came to me. So, General Counsel, are you able to comment on which way to proceed? I like what we're doing. I just want to make sure that we as a government agency are not recommending a specific product.
Yes, Member Sumwalt, and Madam Vice Chairman, my recommendation would be that, as we've done with previous board products, if you would permit staff to research the issue further, and then we can submit our proposal to the board on notation for a resolution of this particular question.
I'm in agreement with that, Member Weiner and Member Sumwalt, since you brought it up. Thank you, Mr. Toshin. So we will follow up on that after the meeting. But
Yeah, I would recommend that the board now vote on all the recommendations as amended, and subject to staff reporting back to the board on the particular issue that Member Sumwalt has raised.
thank you, Mr. Toshin. So subject to, as Mr. Toshin elaborated on, staff following up on that, is there a motion to adopt the findings as amended?
So moved. Seconded.
So the motion to adopt the findings as amended has been moved and seconded, and those in favor, please signal with a hand and say aye.
Aye.
Aye. The vote is 3-0 in favor of adopting the findings as amended, with the caveat given by Mr. Toshin, the General Counsel. So the findings as amended have been adopted. Mr. Zoller, would you please now read the probable cause, proposed probable cause?
Staff proposes the following probable cause. The NTSB determines that the probable cause of this accident was the flight crew member's failure to perform the flight control check before takeoff, their attempt to take off with the Gust lock system engaged, and their delayed execution of a rejected takeoff after they became aware that the controls were locked. Contributing to the accident were the flight crew's habitual noncompliance with checklists, Gulfstream Aerospace Corporation's failure to ensure that the G4 Gust lock throttle lever interlock system would prevent an attempted takeoff with the Gust lock engaged, and the Federal Aviation Administration's failure to detect this inadequacy during the G4's certification.
Are there any amendments? Is there a motion to adopt the probable cause as proposed?
So moved.
Second.
And Member Sumwalt and Member Weiner, do you have any additional issues for discussion related to the probable cause? Thank you. So the motion has been moved and seconded. Those in favor signal with a hand and say aye. Aye. The vote is 3-0 in favor of adopting the probable cause as proposed. So now, Mr. Zoller, would you please read the proposed recommendations?
As a result of this accident, staff proposes 5 new safety recommendations. There are 3 to the Federal Aviation Administration. 1, identify non-frangible structures outside of a runway safety area during annual 14 Code of Federal Regulations, Part 139 inspections, and place increased emphasis on replacing non-frangible fittings of any objects along the extended runway center line up to the perimeter fence with frangible fittings wherever feasible during the next routine maintenance cycle. 2, after Gulfstream Aerospace Corporation develops a modification of the G4 Gust lock throttle lever interlock, require that the Gust lock system on all existing G4 airplanes be retrofitted to comply with the certification requirement that the Gust lock physically limit the operation of the airplane so that the pilot receives an unmistakable warning at the start of takeoff. And 3, develop and issue guidance on the appropriate use and limitations of the review of engineering drawings in a design review performed as a means of showing compliance with certification regulations. There is one recommendation to the International Business Aviation Council. Amend International Standard for Business Aircraft Operations Auditing Standards to include verifying that operators are complying with best practices for checklist execution, including the use of the challenge verification response format whenever possible. And one recommendation to the National Business Aviation Association. Work with the existing business aviation flight operational quality assurance groups, such as the Corporate Flight Operational Quality Assurance Centerline Steering Committee, to analyze existing data for compliance with manufacturer-required routine flight control checks before takeoff, and provide the results of this analysis to your members as part of your data-driven safety agenda for business aviation. Staff also proposes that the board adopt a safety alert discussing the importance of removing flight control locks and performing flight control checks before takeoff. The safety alert reminds pilots to follow standard operating procedures and use checklists to avoid overlooking these items.
Thank you, Mr. Zoller. And I believe we have an amendment to the recommendations. Member Sumwalt.
I do, and this one is just a little nitnoid, but I would propose in the recommendation to the NBAA, we change the word to analyze existing data for compliance. I'd say we change it to say to analyze existing data for non-compliance, and I'll read it if you like. Work with existing business aviation flight operations flight operational quality assurance groups, such as the Corporate Flight Operational Quality Assurance Centerline Steering Committee, to analyze existing data for non-compliance with manufacturer-required routine flight control checks before takeoff, and provide the results of this analysis to your members as a part of your data-driven safety agenda for business aviation. And that is my motion, and the reason I'd like to make that is that we've talked throughout the report, including in the probable cause, about non-compliance. And having worked in a FOCA office in an airline, I know that you look for the exceedances. You look for those things that are the outliers to understand them. You don't look at your compliance data. You look at the non-compliance data. So it's just a little nitnoid. We're looking at the same side, or different side of the same coin, but that would be my preference. And so there's my motion.
Seconded. So does the staff have a position on this amendment?
Staff concurs.
Thank you, Mr. DeLisi. Do you have any other issues related to this amendment of Member Sumwalt's? Thank you, Member Weiner. So the motion to amend recommendation 5, as stated by Member Sumwalt, has been moved and seconded. Those in favor, please signal with your hand and say aye. Aye. The vote is 3-0 in favor of adopting the recommendation as amended. So the amendment has been adopted. We will move on to the full recommendations and then the safety alert. Is that correct, Mr. Toshin?
Yes, Madam Vice Chairman.
Thank you. Do you have additional comments? Is there a motion to adopt the recommendations as amended?
So moved. Seconded.
The motion to adopt the recommendations as amended has been moved and seconded. And those in favor, please signal with your hand and say aye. Aye. The vote is 3-0 in favor of adopting the recommendations as amended. The recommendations as amended have been adopted. Now the board will vote on the proposed safety alert included in the report as mentioned by Mr. Zoller. Member Weiner, Member Sumwalt, do you have any additional issues related to the safety alert for discussion?
No, ma'am, and I move that we accept it as presented.
Thank you. The motion has been moved and seconded. Those in favor of the safety alert as presented by staff, please signal with a hand and say aye. Aye. And the vote is 3-0 in favor of adopting the safety alert as proposed. So we're concluding this soon, this part of it. Just wanted to check with Member Sumwalt and Member Weiner if you have any additional issues for discussion before we adopt the full report. Okay. Is there a motion to adopt the report as presented?
Seconded.
Excuse me, if the motion could be to adopt the full report as revised.
Thank you, Mr. Toshin. Is there a motion to adopt the report as revised?
So moved.
Seconded.
Thank you. The motion to adopt the report as revised has been seconded. And those in favor, please signal with a hand and say aye. Aye. The vote is 3-0 in favor of adopting the report as revised. And the report as revised has been adopted. Member Sumwalt and Member Weiner, do either of you wish to file either a concurring or a dissenting opinion?
I wish to file a concurring statement.
Thank you, Member Sumwalt. Thank you, Member Weiner. So Member Sumwalt has reserved the right to file a concurring or dissenting, but in his case, he's stating it's a concurring statement to be appended to the report. In closing, I'd first like to recognize the very thorough and hard work of the NTSB staff in producing this report and thank my fellow board members for their thoughtful participation in this process. Thank you. In this investigation, we took a close look into the operation of a business airplane, and today's recommendations, if acted upon, have the potential to make business aviation safer. To their credit, Gulfstream Aerospace Corporation is working on modifications to the G4 Gust lock, and the FAA intends to mandate the modifications once Gulfstream develops them. In support of that intent, we recommend that once the modifications are available, the FAA require implementation on all existing G4 airplanes. We also recommend that the FAA develop and issue guidance on the use of engineering drawing review in the design certification process. And today we call on the International Business Aviation Council to amend international auditing standards to verify that operators complete checklists according to best practices using the challenge verification response format whenever possible. As we've seen in the commercial aviation industry, data analysis is a key component to improving flight operations. Today, we ask the business aviation community to do the same. That is why we recommend the National Business Aviation Association and other business groups analyze data on compliance and noncompliance with manufacturer-required flight control checks and provide the results of that analysis to their members. While our recommendations today will make business aviation safer, it's important to remember that this accident was preventable. It could have been avoided by following established procedures. So in addition to today's recommendations, we will be issuing a safety alert, bringing everyone's attention to the critical need to follow checklists to prevent procedural omissions, such as failing to remove flight control locks, and the need to perform flight control checks before each and every takeoff. Complacency leading to procedural noncompliance has no place in aviation. Together, today's safety recommendations and the safety alert will reduce the risk of complacency and significantly increase the safety of flight. Owners of business aircraft and their passengers deserve this benefit. This accident is proof positive for why procedural compliance is one of our 2015 most wanted list issues. Procedural compliance saves lives. Methodically and routinely following procedures on each and every flight without skipping steps may seem mundane, but it is a cornerstone of aviation safety, and indeed safety in all modes of transportation. Ensuring that procedures are always followed will save lives and prevent injuries. We stand adjourned.